Hello, welcome back. In this video, what I want to do is look at figure 11, which is the characteristic S-curve that we get when we study the logistic model. And I want to talk more about this using tools that we have from Calc I. Okay, Calc I is all about derivatives, which are rates of change. And this section we've been talking about rates of change as well. We've been talking about growth rates. So what I want to do is make the connection between what we did in Calc I, where we studied rates of change, and what we're studying now, where we're studying growth rates, which is also a rate of change. And maybe let me change colors for this. An important difference is that in Calc I, when we study derivatives and rates of change, we are talking about an absolute rate of change. And I'll come back to this in a minute to explain why, but you've already read that in this section, when we talk about growth rates, what we're really looking at is a relative rate of change. Okay, so let's talk about how do I know a derivative is an absolute rate of change? The key difference between an absolute rate of change and a relative rate of change is whether we are just measuring the change in the y values, or if we are measuring the change in the y values relative to the y value itself. So graphically, are we considering the height of the graph when we talk about a rate of change? And when we talk about a derivative, we don't. We talk about dy dx, which represents a small change in x, a small change in y, divided by a small change in x, it's really measuring a slope. But this doesn't mention the value of y itself. So it doesn't matter if I'm talking about a small y value or a big y value. What I really care about is the slope at that point, not the y value. So thinking in terms of this graph, if I shift this graph up and make all of my y values bigger, that doesn't change my derivative. And that's a signal that this is an absolute rather than a relative rate of change. Okay, so hopefully we all accept that the derivative is an absolute rate of change, not a relative one, because I'm not taking into account particular y values. And that means that if I want to make a comparison between derivatives and growth rates, I have to be careful. Because they're not actually measuring the same thing. And that's actually why I want to go through this example, because the logistic curve has a characteristic shape that your book describes in terms of growth rates, but I think having taken calculus, many of us think in terms of absolute rates of change instead. And I want to compare the two so that you can build your intuition from this graph. So what we'll find is that this curve, even though it's quite shallow at the beginning, has high growth rates at the beginning. The absolute rates of change are going to be small, but because the y values are also small, the relative rates of change will be big. And that's part of the logistic growth curve, is it starts out with a large relative growth rate, even though the graph is quite flat. That growth rate actually, in the middle where the absolute rate of change is quite large, the growth rate starts to level out. And then at the top, I have both small absolute rates of change and small relative rates of change. So let's compare the two. Let's start by looking at this graph and find the absolute rates of change. And then we'll compare those to the relative rates of change at the same places. Okay, so I'm going to pick 2 points to do this at, and I'm going to have you do the third one on your own. We're going to compare t equal to 20, which is relatively early in my graph, to t equal to 50, which is right in the middle, and then you're going to look at t equal to 80 on your own. So let's start with 20. At t equal to 20, if I want to know what my derivative is, what my absolute rate of change is, I can approximate it using a graph by sketching the tangent line. So if I draw my tangent line, it's going to look something like this. And I want to approximate the slope of the tangent line. Remember, that's what a derivative is. And one way of doing that is using a right triangle. The slope of this line is rise over 1, so what I need is a way to figure out rise over 1. So I draw this right triangle, and I chose that specifically for the side length to be 20 to make my approximations easier. And if I look at this side, it looks like this side might be about 10. So the approximation that I get for the slope of this line is rise 10 over run 20. So my slope is about 1/2. And that's my derivative, so t equal to 20. The derivative, or the absolute rate of change, is about 1/2. Or 50%. Okay, but what does that tell me about the relative rate of change or the growth rate? Well, the relative change in a quantity is just the absolute change divided by the value of the quantity. So to get from the derivative to the growth rate, what we're going to do is divide by the quantity. So it's going to be 1/2 divided by, let's scroll up, at 20, my y value is about 10. Let's just say 10 to make the math easy. So what I get is that my growth rate at that point is 1/20, which is 5%. Which doesn't seem very large, but what we'll see is that is large compared to the growth rate that we get at the other points. Okay, let's try t equal to 50 now and see what we get. We'll start by finding the absolute rate of change using the derivative. And we'll approximate that the same way. We'll go back to our graph and sketch the tangent line and then try to figure out what the slope of the tangent line is. So at 50, let's see, I'm right about here. So when I sketch my tangent line, it's going to look something like this, and my goal is to figure out what the slope of that tangent line is. So let me start by drawing a right triangle that has that tangent line as its hypotenuse, and I want to estimate the height and the width of this triangle, and I again drew this so that one of them was 20 to try to make my estimation easier. And that means I have to estimate what this side length is. It's not quite 10. It looks like maybe it's about 1/3 of this length, which is 20. So maybe let's call that 6. Which means that the slope of my line at that point is approximately 20 divided by 6, which is 3.3 repeating. Then the growth rate at that point should still be high because this is actually right when I start to feel the effect of the limits of growth. So the growth rate should still be pretty high here. And see, the growth rate is going to be our absolute rate of change divided by our quantity. So it's going to be 3.3 divided by, let's go back, see what our height is at 50. When t is equal to 50, it looks like our stock level is approximately 50 also. So I'll divide that by 50 as well. And that comes out to a growth rate of about, let's see, that's 0.06 repeating. So if I round, that's about 6.7%. Which is actually good, because what I should be getting is that for the first half of my graph, even though the absolute rates of change are changing quite a lot, the derivative starts out really small and then is going to get bigger, the growth rate for the first half should be similar to the growth rate of an exponential function. So it should be pretty much constant until I hit this midpoint, and then it's going to start decreasing. Okay, and what I'll have you do then to check that it's decreasing is repeat this for t equal to 80. In your notes for this section, I want you to find the rate of change using the derivative, so approximating the derivative using the graph, and use that to calculate the growth rate as well. And what you should notice is that the rate of change at t equal to 80 is actually going to be pretty similar to the rate of change at t equal to 20. But the relative growth rate is going to be much smaller. So you should get something about 1/2 for its derivative, but you'll notice that that means that the growth rate at that point is a much smaller number. Okay, so that's what I wanted to point out about this figure in your book, and I wanted, because we tend to think of growth rates the way that or rates of change the way that we learned about them in calculus, I wanted you to be able to make the jump from rates of change absolute to these relative rates of change that are given by the growth rates.